Hello students, very good afternoon. Today we are going to see the one of the important topic in the power system 2 subject, that is unit commitment. So we all know that there are n number of power plants running simultaneously to meet out the demand of the consumer. So in such a case we have to select which type of power plant to be operated at which time. Sometimes we are in need of thermal power plant, sometimes we are in need of hydro power plant, sometimes we are in need of solar power plant. So based upon the per unit cost of the each power plant, we have to select the right power plant for the right application. So thank you for your patient listening. We will be discussing the chart in detail in the upcoming video.
So myself Harshavardhan. So I'm going to speak about different types of uh, power plants. So we have six types of power plants, which and all are thermal, hydro, wind, solar, geothermal, and nuclear. So when we talk about this topic, the thermal, hydro, wind, and solar, most probably these are renewable and non renewable also. So if we consider hydro, wind, and solar, they are renewable sources. So whenever it is available naturally, so easily we can get energy from it. And the thermal, geothermal, and nuclear, these are the non-renewable sources. We have to burn the fossil fuels or nuclear fissions, etc. So we are going to see about the power plants and the systems elaborately using unit commitment.
These are the main factors to be considered for unit commitment. There are six main factors: power demand, generator limits, startup and shutdown costs, minimum on-off time, ramp rate, reserve requirement. Power demand, the power demands on the load. Generator limits should be set for maximum and minimum power. Startup and shutdown costs, minimum on-off time, ramp rate. This is about how fast the output change. Reserve requirement for extra power.
So these are all the main factors to be considered for the unit commitment. The first one is the power demand. The ultimate aim of the power system is to meet out the demand of the consumers around the clock 24 cross 7. So first thing we have to consider the power demand. What is the demand? So for meet out the demand, how many power stations to be operated? That is what the main consideration. That's why it comes in the first list. Then second one, generator limits. So for each limit there is an 5 generator, there is a limit. So we should not overload the generator. For that we have to stick on to the generator limit. So the in that I have mentioned minimum power and maximum power. Then third one, startup and shutdown cost. So this is one of the interesting factor to be considered in the unit commitment, because for turn on and turn off the power stations, the certain cost involved. For example, if you take the thermal power plant, we are in need of minimum of 2 days time to bring into an action. In case of nuclear power plant, it will take around 1 week to come into an action. So for that 1 week you have to spend the amount. So for that, the startup and shutdown costs to be considered. Then minimum off time and on time is the thing which tells us how much time the power station can be in continuous on. So based on that also we have to select the unit to be allotted. Then ramp rate means the output rate. Then finally the reserve requirement. There are three types of reserve: spinning reserve, online reserve, offline reserve. So based on the type of reserve we have to choose. So these are all the six main factors to be considered for the unit commitment.
Hello everyone, here is the graph of x-axis and y-axis. X-axis is an shows an hours, y-axis shows in the load in megawatts. In graph here is a river plant, thermal plant and pumped storage plant. River plant is a low cost, thermal plant is a medium cost, and pumped storage plant is the rarer.
So guys, this unit commitment graph tells us which type of power plant to be used at which time. So we have plot the graph of 12 to 12 and again 12 to 12, morning hours and evening hours. So the base load is taken from the river power plant, and the mid load is taken from the thermal power plant, and the peak load is taken from the pumped storage plant. So the cost wise, this is very very lower cost. It is a moderate cost. This is a high cost. So the moderate cost is used in the mid range, and the low cost is used throughout the day, and the high cost is used very very often. So what this unit commitment tells is which type of power plant to be used at which time. So obviously the low cost power plant to be used all the time, medium cost power plant to be used for the short time, and very high cost power plant to be used for the very rare time. So this is what the unit commitment tells.